Hi, Assalamualaikum. Welcome back to my channel, Physics from 5 SSM. Today we continue 3.2 resistance part 2. In this video, I will discuss on two learning standards, solve problems involving combination of series and parallel circuits. The second one, define resistivity of wire. What is resistance? In my first video, we have derived that from the graph of V against I, gradient of the graph is equals to resistance. We have derived the formula for resistance. Let's look at definition of resistance. So resistance is defined as the ratio of potential difference V to current I, or potential difference V divided by current I. So based on the formula, we get R equals to V divided by I. Unit volt divide ampere, or volt ampere to the power negative 1, and equals to ohm. In an electric circuit, resistance actually is the degree to which substance opposes flow of electric current through it. If we carried out an experiment using constant wire, how the constant wire oppose the flow of electric current through it? Meaning constant wire has resistance. All substances resist electron flow to some extent. The relationship between R and I is inversely proportional if the voltage is kept constant. So from here, because of resistance opposes the flow of current, thus if resistance is more, current will become less. If resistance is less, current will become more. So that's the relationship between resistance and current. Resistance is measured in ohms using an ohmmeter. An ohmmeter is device for measuring resistance. Ohmmeters are connected in parallel. Okay, the first circuit is series circuit. The second circuit is parallel circuit. Let's look at one by one. The first one for series circuit. The first thing that you do, you need to mark the current flow. Current always flow from positive to negative, high potential to low potential. Current will pass through ammeter because ammeter has low resistance. So it will flow pass through resistor 1, R1. We can just mark as I1, the current. Pass through R2, current is I2. Pass through R3, current is I3. And then across resistors, connect voltmeter. R1, the voltmeter is V1. R2, voltmeter is V2. R3, voltmeter is V3. The voltmeters are connected in parallel to the resistor. You can see here why there is no current flow through voltmeter. We just mark here the current flow because voltmeter has a very high resistance. Thus, the current that can pass through is very small until we can say equals to 0. Or we can just say voltmeter does not allow current to pass through it. What the voltmeter do here? Just to measure potential difference across resistor. If we look at the current flow in one direction only, or one path. So this shows that current I1 is equals to I2, equals to I3, and equals to total current. How about the potential difference of voltage? The total voltage supplied by the battery is V. Voltmeter measure potential difference between 2 points. This point to this point, and then from this point to this point, and then from this point to this point. So in this case, total voltage supplied is equals to V1 plus V2 plus V3. So in this type of circuit, current flow in one direction, thus all resistance experience same current, but the resistance sharing voltage. Okay. Okay, now let's look at the total resistance of the circuit, or we can say effective resistance. As we know from the formula, V equals to IR. If you want to determine the value of total current, I equals to total voltage divided by total resistance. So in this case, we have more than one resistors. So the value of R must be total resistance, or we call it effective resistance. For series connection, the total effective resistance is R1 plus R2 plus R3. Okay, let's look at the parallel circuit. When you mark the current flow, current will flow from positive terminal to negative terminal. Total current is I. When reach this point, you can see now current split to three paths of flowing. For R1, you can mark as I1, R2 is I2, R3 is I3. Means they are sharing the current. So the total current I is equals to I1 plus I2 plus I3. How about the voltage? Total voltage is V. As you can see here, this point and this point and this point all connected to the same point or same terminal, positive terminal. There's no other resistors here. Same thing, this side, this point, and this point, all connected to the same point, negative terminal. So this shows that reading of the voltmeter V1 equals to V2 equals to V3 and equals to reading of voltmeter across the battery, or total voltage. So we have V equals to V1 equals to V2 equals to V3. So this type of connection, parallel connection, current is shared by all the resistors and the total voltage are same for all resistors. How about the total effective resistance? For effective resistance, we need to use this method or this formula to calculate. 1 over R effective equals to 1 over R1 plus 1 over R2 plus 1 over R3. Then you need to find what is the value of R. Okay, so you will get effective resistance for this type of connection. Okay, let's look at some example involving combination circuit for series and parallel. Example 1, 3 resistors are arranged in series and in parallel. We have R1, R2, R3, 2 ohm, 4 ohm, and 12 ohm respectively. When the switch is closed, calculate effective resistance R, current flowing through 2 ohm resistor and potential difference across it, current flowing through 4 ohm, 12 ohm resistors and potential difference across them respectively. First of all, when you look at the circuit, this circuit is combination of series and parallel. If you look at R2 and R3, they are in parallel because they are sharing the current. R1 and the parallel part are in series. As you can see, current flow in one direction. So now let's try to solve this type of question. This is the circuit just now. R2 and R3 is the parallel part of the circuit. So meaning we need to find the effective resistance for this part and then replace it with a new resistor R4. Meaning this type of activity is like simplify the circuit so that it becomes easier to solve problems. Okay, so effective resistance for the whole circuit is equals to R1 plus R4. R4 is equals to effective resistance for R2 and R3. So how to find effective resistance for R2 and R3? We can calculate using the formula for parallel part. 1 over R4 equals 1 over R2 plus 1 over R3. Means 1 over 4 plus 1 over 12. So we get 4 over 12. Thus, R4 is the reciprocal. Okay, so R4 equals to 12 divided by 4, 3 ohm. So this R4 is equals to 3 ohm. Then we can calculate for effective resistance R equals to R1 plus R4. So 2 plus 3 thus become 5 ohm. So for the whole circuit, effective resistance is 5 ohm. How to calculate the total current? Total current flow in the circuit, I equals to total voltage divided by effective resistance. Because effective resistance actually represents total resistance. So 6 divided by 12. So we get 1.2 ampere. I1 is equals to total current. We want to find the voltage across R1. Thus we use the formula V equals to IR. Across R1 is V1 equals to I1 R1. R1 is 2 ohm. Thus V1 equals to 1.2 ampere multiply 2 ohm. Thus we get 2.4 volt. So voltage across R1 is 2.4 volt. Okay, now we want to solve to find the value of V1, V2 and V3. The total voltage for the across all resistors is total voltage V. So for 4 ohm and 12 ohm resistors, 4 ohm and 12 ohm resistors, we can find the potential difference V equals to V1 plus V2. As V2 equals to V3, they are in parallel. So V2 equals to V minus V1. So 6 minus 2.4. So we get 3.6 volt. This one 2.4 volt. This part 3.6 volt. So total is 6 volt. R2 is parallel to R3. Yeah? So voltage are same, meaning V2 equals to V3. So we get V3 equals to V2 equals to 3.6 volt. So the current flowing through the 4 ohm resistor, I2, using the formula I equals to V divided by R. So you can just substitute I2 equals V2 divided by R2. V2 we have calculated as 3.6 volt. Thus 3.6 divided by 4. So we get I2 0.9 ampere. For the R3 12 ohm resistor, we use the same formula I equals to V divided by R. I3 equals to V3 divided by R3. So 3.6 divided by 12. So we get 0.3 ampere. So you can check again whether the calculation are correct or not. The total current for this circuit is 1.2 ampere. So you can just add again 1.2 plus 1.3, 0.9 plus 0.3, so we get 1.2 ampere. So you can just make a little bit of checking after the calculation. Example 2, figure 3.14 shows 5 resistors connected in combination circuit. Calculate effective resistance R, current flowing through emitter I, potential difference across points A and B, or BAB. Okay, this is also combination circuit, series and parallel. Total voltage supply is 5 volt. Okay, let's look at the solution for this question. You need to mark the current flow first in order to identify the series part and the parallel part. If you mark current flow through 4 ohm, the two resistors here, same current, meaning 4 ohm and 4 ohm here are in series. And then at point A here, the current split to 2, meaning this part and this part are in parallel. And then you can see here 2 ohm and this 2 ohm experience same current, meaning they are in series. So what you do, you need to solve it one by one. For this part, 2 ohm and 2 ohm, you can simplify the circuit. Effective resistance for this part equals to R1. So we can simplify the circuit. For this part, effective resistance is 2 plus 2, thus become 4 ohm. So you can see we can just simplify it to become this circuit. So how to calculate effective resistance for 4 ohm and 4 ohm here? So this parallel part, using the formula 1 over R2 equals 1 over 4 plus 1 over 4. So we get R2 equals to 2 ohm. Again, we can simplify the circuit become 4 ohm, 4 ohm, and then this part is R2. So this R2 equals to 2 ohm. So the total effective resistance for the whole circuit is 4 plus 4 plus 2. So we get 10 ohm. So for the whole circuit, effective resistance is 10 ohm. Okay, next question is current flowing through ammeter. For current flowing through ammeter, we use the formula I equals to V divided by R. If I here is the total current, V must be total voltage, R must be total effective resistance. So we get 5 divided by 10. So we get 0.5 ampere. And then part C, to determine VAB, voltage across point AB, meaning voltage across R2. R2 just now is the parallel circuit that already simplified to become R2. Thus, we can just use R2 straight away. So VAB equals to, now 4 ohm and R2 are in series. So we just straight away use the current flow as total current. So total current passed through AB equals to 0.5 ampere. So we have VAB equals to IR2, total current 0.5, resistance R2 is 2. So we get 1 volt, meaning across AB is 1 volt. Okay, next we want to discuss about resistivity of a conductor rho. We have discussed about resistance. So what is resistivity? Just now, resistance we discussed as a quantity that opposes the flow of current. So what is this resistivity? So resistivity of conductor rho is a measure of a conductor's ability to oppose the flow of electric current. It's the ability of the conductor. The unit of resistivity is ohm meter. For resistance, we just use ohm. For resistivity is ohm meter. The value of resistivity depends on temperature and the nature of conductor material. You can say it depends on material of conductor. Rho, we use a symbol for resistivity of a wire. L, length of wire. A, cross-sectional area of wire. R equals resistance of wire. Thus, resistivity equals to RA divided by L. From here, the SI unit we can determine. Unit for resistance is ohm, unit for area is meter squared, divide by unit for length meter, simplify this one you will get rho meter. So we will discuss more on this about resistivity under topic factors affecting resistance later. Okay. Resistivity of different conductors at temperature 20 degrees Celsius is given. Compare resistance for 5 types of material. We have 5 types of material here: tungsten, constantan, copper, iron, nichrome. Normally, these 5 conductors are good conductors that usually used as a heating element or connecting wire for transmission cable and other purposes. If you look at the value of resistivity, the value is quite small because 10 to the power negative 8, or we can say overall resistivity is low as compared to other conductor. But if we compare among these 5 material, we can see nichrome has the highest resistivity and constantan has the lowest resistivity. Okay, so what we do, we just compare between these 5 types of material because normally these are the material that are used. So high resistant wire, nichrome and tungsten. Okay, nichrome, tungsten. Low resistant, iron, constantan and copper. So later we just make conclusion. If you compare between resistivity of material, if you compare among these 5, nichrome has the highest resistivity, okay, compared to tungsten and the rest one. And the iron has the lowest resistivity compared to constantan and copper. Okay, let's discuss formative practice 3.2. List the factors that affect resistance of a wire. There are 4 factors: length of wire, cross-sectional area of wire, resistivity and temperature. That one is based on the formula that we have discussed before. Number 2, calculate total resistance of coil of copper wire with a length of 50 meter and cross-sectional area 2.5 millimeter squared, given that resistivity of copper at temperature 20 is 1.72 times 10 to the power negative 8 rho meter. So wire length L equals to 50 meter, cross-sectional area 2.5 millimeter squared, resistivity of copper also given, thus we get R equals to rho L divided by A. So we get rho given, L is 50 divided by area. Thus we get 0.344 ohm. The area given in millimeter squared, you need to convert to meter squared. Okay, the total resistance for this conductor is equals to 0.344 ohm. Okay, this is extra exercise for combination of circuit, parallel and series. For the first one, what is reading of ammeter? Meaning total current. So what you do, the first step, you need to find total effective resistance. For the parallel part, you calculate the effective resistance, you will get equals to 2 ohm. 1 over 6 plus 1 over 3. So you get 2 ohm. 2 ohm and 4 ohm series, so 4 plus 2 equals to 6 ohm, meaning effective resistance is 6 ohm. Current equals to V divided by R. V is total voltage 3 divided by effective resistance 6, so you get 0.5 ampere. So reading of ammeter equals to 0.5 ampere. What is potential difference across parallel network, meaning this part? V equals to IR. Just now we already calculated for parallel part as 2 ohm. So you can just use the value straight away. V equals to IR. So I is 0.5 multiply 2. So you get 1 volt. What is current flowing through 6 ohm? This one, this one. You can just mark as I1 for example. So just look at across 6 ohm only. So I is to 1 volt. So divide by 6. So we get 0.17 ampere. So current passed through 6 ohm is 0.17 ampere. If you want to find current flowing through 3 ohm, you just take 0.5 minus 0.17. Okay, so you will get 0.33 ampere. Okay, number 2, what is ammeter reading when the switch is closed? Same thing, for the first part, you need to find effective resistance. Parallel part, effective resistance is 4 ohm. So for the whole circuit is 8 plus 4, 12 ohm. Total current flow is total voltage divided by effective resistance. So total voltage 20 divided by 12. So we get 1.67 ampere. So that one is reading of ammeter or total current. Part B, for parallel part effective resistance is 1 ohm. So effective resistance for the whole circuit is 8 plus 1 equals to 9 ohm. Total current flow in the circuit I equals to V divided by R is equals to 4.5 divided by 9. Total voltage divided by effective resistance. So we get 0.5 ampere. And then I1 equals to 0.5 divided by 2. So V divided by 2. Because I just now, we get 0.5 ampere. So for the whole circuit is 0.5 ampere. So we get 0.5 divided by 2. So 0.25 ampere. Why we divide by 2? Because this one identical resistor. Same resistance, thus the current also same. So 0.25 ampere for current for resistor 2 ohm. Okay, this one 0.25 ampere, this one also 0.25 ampere. Part C, total effective resistance. For the parallel part, you calculate, you will get equals to 1 over 6 plus 1 over 2. And then you just add, you will get the total voltage equals to 12 ohm. So for the whole circuit is 12 ohm. Total current, total voltage divided by effective resistance equals to 2 ampere. And V1 equals to 2 times 1.5 for the parallel part. For the parallel part is V1. So effective resistance is 1.5, effective resistance for this part. So V equals to IR. Total current is 2 ampere, so 2 times 1.5, so we get 3 volt. I1 equals to 3 divided by 6, meaning the reading of ammeter here. So you can just put as I1. I1 equals to total voltage across 6 ohm, which is equals to 3 volt, divided by resistance 6 ohm. So we get 0.5 ampere. So across 6 ohm is 0.5 ampere. And then for 2 ohm, it will become 1.5 ampere because the total current here equals to 2 ampere. Okay, that's all for this topic today. Thank you for watching.